All right.
Okay, so recording started. Welcome to SQL Server. Welcome to LA Data Platform. Used to be SQL Malibu. Today we have a session by Steve Jones, Containers, Kubernetes, and SQL Server. I'm personally excited to know what Kubernetes is. I'm guessing. And of course, one of the sponsors of this meeting is Redgate, surprisingly, which Steve Jones is part of. Welcome to the session.
Thank you, Steve. Thanks, everybody, and welcome. And hopefully everybody is healthy and doing well out there in LA or wherever you are. So the agenda, as I have real quick, I'm going to spend most of my time talking about containers because they kind of set the basis for what this thing is. And then we'll get into a little bit of Kubernetes, and then I'll try to bring it together with how does this fit with SQL Server a little bit. I love containers. I think it's a fascinating technology and concept. So hopefully you do the same as well. Yeah, we are recording this, but if you do have questions, feel free to unmute and say hi or ask me a question at some point. I don't see the chat window when I'm presenting, so either if you type something in there, Steve, maybe you want to interrupt me. Otherwise, just unmute and we'll get going. So as Steve mentioned, I'm Steve Jones. I do work for Redgate Software as, well, I was an evangelist who actually changed to advocate just recently, so I have to fix that. But I'm also the editor of SQL Server Central, which I've been running for close to 20 years now. I founded that site with a few other partners, and our goal there was to kind of help everyone in the world become better at working with SQL Server or being a better data professional every day. But on top of that, I spent over 10 years before that as a real data professional. I've been a DBA, I've been a developer, a manager, in a variety of companies, big, small, regulated, non-regulated. And so I have a bunch of different experience in actually building software and running software for different companies. Microsoft has also honored me as an MVP, and so I've had that for a while. And then my contact information is here at the bottom, but please feel free to get a hold of me if you need to, and I'll show this again at the end. So let's start with a little demo. So I like to do this. Let's start with a little demo, and then let me find my management studio, which is somewhere in here. I'm going to connect to an instance, and this is the kind of thing all of you do every day. Hopefully Management Studio will actually cooperate. Where, I know I've got something out there running, or I'm doing development on my local machine, and I want to connect to some instance. And so hopefully at some point I'll be able to do that, and we'll connect. This is one of the downsides of a very fat, thick client like SSMS, is that it sometimes does too much stuff that you don't want it to do. So it's in changing its connection, it got a little bit hung up here. So we should connect to just dot or the local default instance here on this machine. So I'm using all the defaults that I would normally use with Management Studio, and Management Studio is still not happy. And I'm using SQL authentication because Windows authentication in containers right now is a little bit complex, to say the least, but it's getting better and better. Microsoft's working on it. So let's try this again and see if this connects. It should connect. Hopefully I don't have to restart Management Studio because that ruins most everybody's afternoon when that happens. Come on. Let's see if things, it did have an error here. Maybe that's the problem. Oh. Well, obviously we're doing containers here. So we'll see some things here. So we want to, that should work. All right. So of course it wasn't running for some reason. I had something stopped there. Nope. That's better. Come on. Obviously SQL Server takes a minute to start up. That's the deal there. So I've connected in here. You see I have a server name of some crazy thing. And then this is SQL Server 2019 RTM. Right, it's actually got the GDR applied to it as well. So let's see if we can continue to do stuff. So now what I want to do is I want to run another command. So in this case, I want to switch containers, and I've just got this built as some batch files because it's just a little bit simpler and easier to do that. Notice I'm still connecting to the local host here. I haven't changed the query at all. I'm just going to run the query. And what I have now is a different host and a different version of SQL Server. All right, so right here, you can see that RTM for 2019 and 2017, both running as those default instances, right? Which is not something that's necessarily easy to do. Even if I had multiple instances installed and I was doing network configuration stuff, I'm not doing that, right? By the way, I'm not doing PowerShell to remove network configuration around and do any of the crazy stuff that I might have to do if I was trying to simulate multiple instances on 1433. But notice I don't have instance names here at all. These are all running just on the same local 1433 as default instances. And here I've got another one here. So right now here, after I fixed my little issue, inside of 3 or 4 minutes, we've run 3 different instances as default instances on this machine with containers. And this is, there's not a lot of install or anything else, as you'll see. And this is one of those powerful things, I think, with containers that simplify your life dramatically. And as I've worked with containers over the last few years, I've seen a lot of things similar to this that constantly make me rethink how I do work and what the advantages of containers are. So let's move on. Let's talk a little bit about containers and virtual machines and help you to understand this. So many of you are familiar these days. Most of us probably have run virtualization somewhere where we've got physical hardware and then we install some operating system. It might be a very thin firmware layer, but it's something. And then we put a hypervisor of some sort. It could be, VirtualBox, Zen, VMware, Hyper-V. Doesn't really matter. There's some virtual hypervisor we put. And then we emulate a machine, a real physical machine. We install an operating system, and then we install our applications, SQL Server, a web server, whatever thing I'm trying to do. And on that physical hardware, I can repeat this process multiple times, subject to some sort of resource limit in my system. Okay, and this is a paradigm that for 20 years has worked pretty well. I think I first ran VMware back in '99. And we use it for various purposes, but it's grown tremendously, and most of us are comfortable these days with dropping a SQL Server on a VM somewhere. Now with containers, it's slightly different. We still have our physical hardware, and we have our operating system, but then we have a runtime, and the Docker one is the most common one, but it's not the only one. And this is deliberately shown as thinner than a hypervisor because it is thinner. It's a much less resource-intensive piece of software. And then you'll notice we don't emulate a machine and we don't install an operating system again. Instead, what we do is we have this thing called an image, and we use that to instantiate a container. And just like with VMs, I can instantiate multiple containers. But the advantage with containers is because they're so lightweight, the density of what I can do with containers is much, much higher than what I can do with virtual machines. So, what is actually a container? I've actually been talking with people about containers for about, almost 11 years now. So the Linux world wanted to have a lighter weight virtual machine, essentially, is what they really wanted to do. So containers were started as a project on Linux, and the LXC project started, I think, in 2008 or 2009. And the idea was that this would give us some way to run an isolated environment without all of the heavyweight nature of VM. Docker was actually a web hosting company, and they were trying to find ways to increase the density of the stuff they hosted on a physical machine. And so they actually ended up building their kind of own engine and API layer, which became very popular. But it's not that hard to do, and it's not that proprietary. And you can see these days, Docker as a company is actually struggling because the whole container thing is not really that hard, that complex. It turns out it's not. And the reason is that we're not doing a virtual machine. Instead, what we're doing is a virtual operating system. So we still use the host kernel, Right? So that means that my container kernel needs to match my host. So, Windows to Windows, Linux to Linux, Unix to Unix, doesn't really matter. But I have to match because I'm using that host kernel to actually execute instructions. But what I am doing is I'm separating out an application in this container. And I'm doing that by virtualizing the OS in two ways. I use namespaces, which for those of you developers, you understand namespaces are ways to allow us to separate out a group of code from another group, right? It can have the same name in one area as in another one. In the database world, we do this with schemas. Right? So I can have a customers table in the DBO schema and also a customers table in the sales schema. In the OS, we use a namespace so that we can separate out processes. So on Linux, every Linux machine has a process ID of 1. That's the base process that's running your system. With a namespace, I can have multiple PID1s in my system. For Windows, we have things like LSASS, the print spooler, the netlogon service, etc. I can have multiple copies of those in the same kernel by using namespace separation. The control groups are a way of doing resource governance because I don't want any particular process to take over all of my resources, especially in the case where that process thinks it owns the entire machine because it's isolated. So control groups allow us to just do some resource governance and ensure that not too many resources go to one particular item. So in that diagram, I had a thing called an image. So an image is actually a template of your file system. Now, if you stop and think for a minute about what a computer is, right? A computer is actually two things. One is I have an execution engine. So I have a CPU and RAM where I move instructions and data in and I operate on them and change them and move them back out. And that's the real-time aspect of a computer. But the other part of the computer, the part that really gets things moving, is the file system, right? Whether that's, RAM, disk, firmware. It's something that bootstraps and actually says, what things am I going to load into the execution engine? So the image is a template of this actual file system that is all of the stuff that makes up the static portion of the computer. And in the container world, what we do is we layer up changes into one big final view of what our computer is. The reason we do layers is it becomes more efficient when we transfer these things around because I don't have to copy layers I already have copied. But I'm essentially trying to just say different states of the file system are what I'm capturing. And then inside the container, we use what's called a unified file system that squashes those layers and gives me a consistent view. So if I create a folder, that's a change. If I put files in that folder, that's another change. The end result is I have a folder with files in it, but that could be 3 layers, right? An empty file system, a folder being added, and then files being copied. The unified file system gives me a consistent view of that. However, it's read-only. Images are read-only, and so they are used to stamp out instantiations of a container. We download the image, and then we use it to create an instance of the container. And I just keep reusing this read-only copy in all of the containers that I have. Let me just to show you really quickly what that looks like. I have some images here on my machine. So you can see on the left, you've got the kind of name of the machine, and then the middle is a tag. And then on the right, far right, you have a size. So you can see I have a bunch of SQL Server images here. They're all fairly small, under 2 gig, right? 1.5 gigs or so. I've got various other pieces of software in here that are running as well. And these all have layers. And so if I want to look at one of these, so this is one that, here's the latest, the GDR one. It's not latest. It was the latest when I got it, but it's the GDR one. Here is the history of what happened. And so if I scroll over here, what you can see is this is actually the base, and then we layer it going up. So the first thing they did was they copied a bunch of files into this image. This was probably a base Windows image. They copied some stuff in there, 100 meg worth of stuff. They ran a bash command in here. Here they removed some stuff. Here they made a directory, which is a pretty small operation. Then there's some of these no ops, right? Like I have a command that's going to run. Didn't change anything. Here I'm going to do a thing like I'm going to put metadata in there. I'm going to configure networking. These essentially don't do any changes to the size, but they are a change in the file system somewhere at a very minor level. So all of these things squash together to give us that image. And when you build your own containers, or when you think about it, you'll do the same thing. You will build up an image like this by performing various operations on it. And then at the end, you'll have a final result that is the software, the thing that you want to run. All right, so I've talked about images a little bit, slightly about containers. The container is an instance. So like I showed in the diagram, we stamp out a copy of that, not a copy, but we use that image to create this virtual OS and start running it. And then the container is that instance that's running it. It's the separated namespace, the control groups around it. And then there's actually a thin writable layer, because the computer actually does need to write data. We have page files, we have configuration changes, things that happen on our systems as we run software. And so I need a writable layer. And so this container actually is just the read-only image that it's using, and they're all shared by the containers built from the image. A thin writable layer where I can make changes, and then the virtual space in the OS where I can actually execute things. Now, as I make changes, as I do things, they change in this writable layer. That writable layer exists as long as the container is alive. So just like a computer, I can pause it, I can stop it, restart it. That writable layer exists. However, if I destroy the container, it's the equivalent of reformatting my machine. In essence, I've lost all of those changes and I have to rebuild a new one, which means I've lost all of the changes I've done since I installed it or stamped it out from sysprep or whatever thing I did. I also do have the ability to mount volumes from external sources, which becomes important later, and it's especially important to us as database people. So I'm going to show you as I can run multiple containers at once. So let me clear my screen. So you can see here, I don't have any containers running right now. If I did, they would show up here. This is equivalent to, running sysinternals, the process executable, or, querying on Linux for processes or anything else. So in this case, I've got a few containers that I want to run, and I've put them in batch files. And this time I'm showing you the commands, which is just a Docker run command with a bunch of parameters that we're putting out there. And at the end, Docker returns some ID, which tells me what's running. And if I look here, you'll see my two containers are actually running. And so I can kind of keep an eye on what's happening and see what's going on. I know these containers are running because if I come over here and reconnect, I have one of these running on 1433 right here. And then I have a second one that's running on 5143. 51433, right? And so let's grab this, put it over here, execute it. Didn't want to do that. Yes.
There is a question. Are these templates available on Microsoft website?
Hold that for a minute. We'll get to it.
Okay.
Yeah, we'll get to it in a minute. So here are the two things I just ran, right? So you can see they're both the same version because they're stamped off of the same image. So if you come here, I did 2017 latest, which is the name or the tag that's on that particular image. So they are the same, but they're actually separate things. And I can show you that here. Actually, let's do it this way. So I've got a little script here. I probably want that on, doesn't matter. I'm going to restore a database, in essence. Okay, and it's going to just do a restore. There's nothing magic about it. I'm going to, as you would expect, right, I can query a database. I can query what's in the data in there. I can add data to that database here and select it back, and I'll see the data there, right? Nothing magic. It's just SQL Server. And a lot of what Microsoft's done in the last few years is to try to make things just SQL Server. And I didn't want that there. I want it here. Sorry, I'm looking down at the bottom to see which one I'm connected to. So I'll restore the database again here, and it should work. And let's put that over there so we can see it better. now if I come over here and run the same query, what I see is, well, I had the same data, but obviously I added an insert here that's different. They're completely separate items. Now, in both cases, I actually had mapped the volume to the same place, so I was restoring off the same backup, which is why I could run the same code in both places. This is the equivalent of me having two instances there. But I started and got these instances running in a few seconds, right? And I didn't have to install software. Even if I'd have done this from scratch, I wouldn't have had to install the software to make this work. And I don't have to do any kind of the administrative stuff of getting things ready. Obviously, I just need a backup file to restore, and I have the code that I can run. But other than that, I haven't done any work. And that's part of the advantage of these containers, is that they're separate, they're simple, they're lightweight, they run very quickly, and they give me some of these advantages that we sometimes don't think about as individuals, but in an organization, when we're trying to manage lots of instances, find places to put them and do resources, it's a hassle. And I can start and stop these very, very quickly. And as you saw earlier, I could have them all looking like default instances, which means I could actually test my software in multiple versions as a default instance, which is something that's hard to do in a host. And with a VM, I have a big heavyweight overhead of trying to run that. All right, so let's start to talk a little bit about how this starts to fit into our world a little. So Microsoft has made a big investment in containers, and they're starting to push forward. Now, originally, this was a Linux project, and Linux had the namespace and control group stuff built in. Most of that was not in Windows, 10 years ago. And so Windows has been working to add container support by giving us APIs into the Windows kernel that allow for namespace creation and control group governance. Now, I did say earlier that we have to allow the kernel to run on the host. So a Linux container needs a Linux kernel, Windows container needs a Windows kernel. That's true. But on Windows, we have the advantage that Microsoft added the Windows subsystem for Linux a few years ago. And actually the 2.0 version is coming. And so that allows us to actually run Linux containers on a Windows machine, which is what I'm doing here. I'm actually running Linux containers. Because if I go back and we were to look at this container actually thinks it's running on Ubuntu 16.04 because I have the Windows subsystem for Linux on my machine running. Now, Linux containers are more advanced and they actually have no resource constraints. So if I were to pick up a 128 core box running Linux and I create a container, I could see 128 cores and run them. Windows has had some constraints and limits. They're getting better about this, and Windows is working hard to create some parity. But right now, I think Linux containers are the choice if you were going to actually run these things in production. We'll see how this changes over time. Windows team has been relatively quiet talking about this. So for now, if you were going to run SQL Server in containers, you'd probably be looking at Linux. If you haven't tried the Windows subsystem for Linux, you can go to the Windows store and actually get it and install it, and you can actually run Bash on your Windows machine and go crazy with Linux stuff if you want to do that. Now, one of the things that we need to do to keep track of images is I need a place to store them. In organizations, this could be a file share somewhere, but in general, the protocol or the convention that we've had is that we create what's called a registry, which is a repository where we store images. And this is probably the reason that Docker became so popular, is that they were willing to host these images for many other companies. And so you could actually go to the Docker hub and get images from various sources. So if you wanted to run, Apache as a web server, you could go get that. If you wanted to run Jenkins as a CI server, you could get that. If you wanted to run SQL Server, you could go get that. So the hub.docker.com is where most of these were stored. Now, Docker did allow you to license the Docker hub, have private repositories, just like GitHub has had. And they also allowed you to have the software inside your enterprise, and you could install your own repository and then keep all your images and your software inside. That worked fine. The Docker hub is still a fantastic place. but Microsoft has moved away from it. So they've deprecated their stuff up there. I don't believe they're going to put any more images up there. From now on, they have their own registry at mcr.microsoft.com. And when I list all the images that I have, you can see that the name for some of these images is mcr.microsoft.com because Microsoft has kind of branded them. Whereas this Jenkins image, these two, this is actually the Jenkins image came from Docker Hub here, and then this is a custom one that I built. This is a custom one I built. This is one I built. Here's Nginx, Postgres, Redis, Alpine. These are all from the Docker Hub. And what I would just do when you do those, you just issue a command to pull those images down to your side. But that's where you actually store images, and that's where you get them from. Now you'll keep a copy on your machine, and if you were building or managing SQL Server, you'd probably have a copy on each of the hosts that run SQL Server. And when they release a new CU, you'd go download the new version from Microsoft. You might customize it because you have certain things that you always do on your machines, and then deploy that to your developers or to your production machines. Hopefully that answers the question about where we get those images. If I were to, let me just do this real quick, so I can show you. The Alpine image is very small. So if I remove this image, right, it's gone. And so I don't see it, but what I could do is Docker pull Alpine. And so by default, it pulls the latest one, and you can see that it's just copying stuff down from the Docker Hub. And that's essentially what's involved in getting these images down. All right. So I've got images down, right? Kind of explain a little bit about those. How do I make them into containers, or how do I get a custom container? So I had a few custom images there as well. I can customize the container when I start it. And so when I started some of those in the demo, you saw I had all these parameters that I added in the batch file to run this. These are the common ones you would use with SQL Server, though there are other ones that might come into play as well. So I have volumes, I have ports, various things. The general convention is for all these parameters that the host value is first and the guest value is second, or the container value is second. So for the port, I might say 51433 is what my host sees. That's the one I use to connect, but 1433 is what's mapped inside the container. It's just like I would do with a router, or if I were trying to transit some firewall, I would do the same type of thing. There's environment variables. So for example, I need to accept a EULA and put a password in. I can run the container disconnected, which means that my command prompt comes back to me, or I could run it interactively, which would let me access the system like I'd logged on to a terminal of some sort. There's all these parameters, but these are one way that I can customize the behavior of the image when I run it, or the behavior of the container.
Steve?
Yes.
Quick question. How does the licensing works if you can download the image?
So the licensing is the same as you normally have. Modern SQL Server is multi-version, all-in-one package. So when I start this up and run it, I'm actually running as Developer Edition. There are parameters you can pass in to say run this as Standard Edition.
Got it.
Or run this as Enterprise Edition. Now the licensing, just like a normal SQL Server, I can install it, and they're not really checking anything, but I'm responsible that I've licensed cores appropriately or connections or whatever I've done. Make sense?
So, well, let's say in case that you started with Standard and at some point you need to upgrade to Enterprise, would you need to re-download a new image, or you can upgrade?
So the image is the same. You're actually setting,
features.
There would be another variable that you would pass in that would say that I'm gonna, you would have to get rid of the container, right? So I'd have persistent storage. I'd stop the container. I'd restart a new container that said, I want to run this as Enterprise, but the image is the same.
Got it. Thank
Okay.
you.
Yep. Now I said that, containers have a writable layer, but it's ephemeral. It goes away when the container dies. That's bad for those of us that are data professionals. And this was one of those sticking points I had early, like, what is the advantage of containers if, the storage has to be external anyways? We'll talk about that in a minute, but suffice it to say, we can have external storage to these containers. And so in the containers that I actually did, I had mapped a volume in there. And if I Let me pop open one of these and look at it. So what you'll see in here, when I ran this, I actually mapped a volume in here. So I mapped, this is the host, and then this is a container. So it's Linux, so you have to know Linux pathing, right? So /SQL/var/whatever is there. In this case, I'm C Docker SQL, and I actually have that here. And so in this C Docker SQL, you can see I had a backup file, and I had various other files that were in there. I mapped those into the container, and then when I ran the restore command, let's look at that. Let's close these because you don't need these right now. This restore command was /SQL/SimpleTalk because I need Linux pathing for this to actually work. Right? And then with move stuff goes back, macking it to the normal path on Linux is var opt MSSQL. Right? So that's what I'm doing there with data to try to ensure that I maintain this data. Now, I can have multiple volumes. I can put them, on LUNs. I can do all kinds of crazy stuff. But this is the way that I would typically work with a database inside of a container. Maybe, maybe not, depending on if I'm dev test, but certainly for production, this is what you would do.
Steve, there's
Yes.
a question about specifying resources when you create containers. Can you specify numbers of CPUs or RAM?
You can.
Right.
You can do some resource governance around it. There's a lot of parameters that are available to do networking, to do resource governance, anything that you kind of need. It's kind of an amazing system. I don't, on the laptop, I don't have enough stuff to worry about it, but you might do it. Now, licensing still applies, right? I can affinitize normal SQL Server in a production system, but that doesn't apply to licensing. Right? If I have 8 cores and I affinitize to just 4 cores inside my SQL Server instance, I'm still responsible to license 8 cores. Right? Microsoft does not allow that. So that's one thing you just have to be aware of.
Thank you.
All right. Yep. So now let me go a little further into why containers here. So this is a great quote from Rob Richardson. He's a friend of mine in Phoenix. Maybe Steve can get him to come out and speak sometime or speak remotely. He does a lot of stuff. He had this great quote where he said, developers see these containers as a machine and ops see them as a process. And what he was saying is that, the developers see a container as an actual machine that they work with. They can customize it. They can do anything they need for their application to run. They can ensure that it works the way that they need it to work or that they expect it to work. And when they hand it off to operations, then operations plugs in networking and power, and it's just another process. And this is one of those huge advantages with containers, because typically when developers deploy software somewhere else, there's instructions and there's things that have to be done, and there's places that we have to copy files to and from, and it's a process. And operations sometimes struggles because developers haven't completely specified everything, and operation environments are different than developer environments, and all the things that many of us have dealt with for decades. That doesn't happen with the container. The way that the container runs when the developer builds that image, it's going to run like that on every machine. And so it becomes a very simple thing for operations to just add hardware capacity and just run containers when they need them to run differently. And they don't have to worry about any type of configuration or setup. They just run a container. And so it dramatically simplifies the overhead of running these things. And this is one of the big reasons where containers start to make a lot more sense than VM. Because developers can't take a VM and give it to somebody else and have it work, right? We have naming, we have networking, we have all sorts of things that are problematic with VMs. We don't have that in containers. Containers are vastly simpler. Right? The flip side of that is containers really run one process inside of one application. And so I may need lots of containers to get things done, which is why we have to start doing other things. Building images is what the developers want to do, right? They have to customize it so that when the container is created, it runs a certain way. There's 2 main ways to do this. One is to kind of specify things in real time. So I can start a container from some image and then connect to it and start to do stuff, or I can have an automated fashion. And the main way we do that is what's called a Docker file. So let me start a build and then I'll show you how this works. So I need to do a Docker build, and we'll call this SimpleTalk because that's the database, and I'm going to give it a versioning tag. Doesn't really matter what it is, and say go. And then, of course, I have to tell it this is a parameter, otherwise that's incorrect. And go. All right. This takes a minute to run. So while this is running, what I want to do is actually show you what this looks like. So here's my Docker file. And what I'm doing here is I'm actually kind of doing a build image here. So I'm starting from this base image. So I'm saying start with this Microsoft image. That's CU12 on Ubuntu. I'm going to set a password and accept the EULA so I don't have to do this when I run the container. I'm simplifying it. I'm going to copy some files. I'm going to run a script that'll give me a database. I'm going to delete that. And then what I'm going to do is I'm going to start with a clean image that I'm calling my dev image, accept the EULA, and I'm going to copy some stuff over to that. So I've got kind of a clean image that I can give out. And this is a standard type of process that I would do in building a container that I could give to a developer, right? So we might, start with this base image. We might copy over a standard dev database. We might apply some changes from source control, and then we build a container and we give it to developers. Then they can do their work, and they can, destroy it, restart it, and everything's fine. And then as we change code and deploy it, we can update that image on a regular basis so that they always have the latest version of code. We're sure that everybody uses the right CU build of SQL Server, the right configuration, everything that we want done. Okay. The reason this takes time is because somewhere in here I have to actually run SQL Server and then run the restore, and that takes a little time. So I have this sleep command in there. So this is now done. So if I look, I actually have this image up here now, this SimpleTalk image, and I can run this. I want to run it disconnected. Let's call it LA data, and give it a port, and then SimpleTalk 0.3. All right, so I didn't have to specify the EULA. I still have something I have running, don't I? Managing containers sometimes is fun, so I think I forgot to run something. So Docker, which one's 1433? SQL 17B. So networking is a big deal. If you're not a networking person, networking starts to become part of your life when you do this. Actually, what I have to do is remove the container is still there. I don't specify EULA. I don't have to do some of the other stuff I wanted to do, but I did do before. I can just run this. And now I do have to reconnect to it because don't forget, every time I stop and start a container, it's like a brand new instance of SQL Server started. So there's no persistence here because it's a new thing. And so there's my version, right? That was the CU12 I started with, but then I created this database, right? Which is a different name than it was before. And I have data in it. And I built it off that same backup file that was actually there. So I have the same type of data in there. But this way I can provide a container that isn't just SQL Server with nothing. I can provide a container that's SQL Server. It already has a database. I could have security accounts in here and agent jobs and every kind of thing I needed to actually work with my system, however I needed to do it. Other way to think about doing this, though, is that often I'm going to need multiple containers, especially in development, probably in production too, but certainly development. And I don't want to have to go through this kind of stuff over and over and over again, right? I don't want to stop and start containers, remove them. I don't want to have to run them, run multiple ones, remember parameters. So one of the neat things that Docker did was they built this API around what they call Compose. And Docker Compose is a way of assembling a series of containers together to create an application. It allows me to add services and do networking and really create the complex environment that I need in a consistent fashion for development, production, QA, whatever. More and more I deal with customers now that don't have a web server in a database or a thick client in a database, so many of my customers have 3, 4, 5, 6, 7, 8 or more servers or processes that need to run in different ways. And so giving all those to a developer or having operations spin those up on a new DR instance is a huge hassle. So what Docker Compose allows me to do is to say, here's how this thing should work. By default, it uses this docker-compose.yaml file. And then a developer would just run Docker Compose up to start things or Docker Compose down to shut it down. And we have developers at Redgate that do this because when we sometimes need to simulate multiple different versions of SQL Server testing, they might need to compose up or down multiple services, and they don't want to have to install those, right? Uninstall those. Those of you that do software development realize as I'm building software, especially with services and server components, getting the latest bits and stuff is a hassle. And this makes it much simple. I don't actually have a Docker Compose example I want to run, but here's the sample YAML file that would compose things up. So you can see that I'm defining at the top services, and YAML is kind of an indented markup language. So I have a web application 1 and a database are my 2 services. And then below those, I'll build those. So I have a Docker file to build my web application. For my database, I actually give it an image and then give it my environment variables and ports. And then as a developer, I would just add a command line type Docker Compose up, and it would start up both of these containers with the appropriate networking and connect them and everything else. And in this case, the web application wouldn't start up until the database was actually running because it needs it running. All right. So we have containers, right? They're off images. I can customize these images. I can customize containers when they run. I can run Linux and Windows. Developers can do it. Why would I do this in a database? And this is a question that through probably most of 2015 and half of 2016 argued with Microsoft about, and probably even into 2017, I was struggling to see huge value there. At some point they convinced me. I think probably sometime in late 2017, early 2018, they convinced me this is a good idea. And there's a few reasons why. The first one is a consistent configuration. More and more as I deal with enterprise customers and talking with Microsoft, all of us vastly underestimate the overhead of administering SQL Server at scale, mostly because we're all busy, we have different things going on, and as humans, we're not consistent. So having some consistency between development, between QA, production across many instances is fantastic. But here's the other one, instant upgrades. And that's the thing that I think finally made me really think that this would be a good idea. And a lot of this is due to the fact that Microsoft has done this work. So I'm going to start, no, I'm not. I was going to start an instance, but I have to remove it first. Oh, stop, what was it? Stop LA data. Should have cleaned some of the stuff up and I didn't. And okay, I have some other things here. Yes. I know I can do this all in one command. There's a force thing to do it, but I start to forget what I'm doing if I do that. So I like to kind of do this in a consistent fashion, and then and Docker is a Unix thing, so it is case sensitive. So works now. So I have a container that starts here. This is, I think, one of the neat things that I've seen happen with my containers. So I'm going to open a new, actually, I better connect, again, make sure I'm connected. I've got this script in here somewhere, so let's grab it. All right, I'm connected here. I've just got a normal SQL Server instance here. I'm going to create a database. I'm going to put a table in that database. I'm going to put some data in there right here. And then I've got some code below this that I'm running. And the code below this just adds another row to that table. There's nothing magic here. But what I'm tracking is the time some message, and I'm cracking the database version and the server version. Okay, so I did both these together, right? I'm on CU12. That makes perfect sense. So now I'm going to upgrade my instance. I'm going to upgrade my databases, and this is what I think is one of the cool things happening. So I stopped that container and I started a new container. All right, and I've my storage and all that stuff is mapped in there. Now here's the neat thing. If I try to connect right now, what I get is this interesting message. And my server is in script upgrade mode. Now I could connect with the DAC through here, but what's actually happening is I'm upgrading the SQL Server instance by applying that new container to the same code that was there, essentially the same master MSDB, et cetera, et cetera, et cetera. And so when I've done this, it takes about 70 seconds for this to actually run and upgrade the system. But when I get done, it will actually have upgraded my SQL Server pretty quickly. And this is, in fact, quicker than I could do it if I ran the CU patch file that I download from Microsoft. And so hopefully this will happen. Everybody, I'm going to take a drink. You guys relax for a second. At some point, we're going to actually connect.
Steve?
Yes.
In all fairness, I think when you applying CU, you can choose things that you don't want to be upgraded. Right?
You could, right?
That's
and
pretty much blank upgrade everything.
You could, but don't forget, this is just a single SQL Server instance here. So there isn't some shared SSIS thing, right? There's no SSAS here. This is all just an instance. And that's, and in a container world, you would actually separate those out. So in this case, what I've done is I've just applied CU15, right? So just go with me a minute, right? So I created a database that was CU12, now it's CU15, right? And that's the current version that we're running, okay? But look at this. This, I think, is the interesting thing. So now I want to stop that one and I want to upgrade again, okay? And so again, it should take about 70 seconds to do this. And I can actually look at this with, I can look at the logs and see what's going on. So you see the normal startup stuff, right? Database is upgrading, and if I run this again, I will be a little bit further along, and we'll see what's going on as it's going. And it's going through the process that you would normally see logged if you looked at one of the setup files after applying a CU. If you went through that, you would see that there's all this stuff going on. And so this work that is happening in the background is stuff that Microsoft did in adding the resource database and making some changes in SQL Server 2017 and later to allow this to work. So I'm going to keep the same script. Hopefully I can connect in here any second now. I should be able to connect in. And in this case, the upgrade is a little bit different when it finally connects because of work that Microsoft has done. It's allowed me to do something here in containers that I couldn't do without containers. There's been one time I actually had my phone out and I started the timer so I could keep track of this and have an idea what's going on, but that should be there. Of course, that was when it worked. So we'll run the same code here. And now look at this. We upgraded and we downgraded through CUs in about 3 minutes. Now that I couldn't easily do with a hotfix. I don't know how many of you actually downgraded a hotfix, but it is often less than an exciting experience. And Microsoft is being really careful about this DB version and not revving it in between major versions for this exact purpose. So if some of you had been on 2019 and you applied CU2, you might have found that there was a bug. There was another enum bug in Agent. And so if you wanted to go back to CU1, you would have had to uninstall, reinstall, rebuild master, restore it, et cetera, et cetera. If you were in containers, you could have just gone back to CU1 in a couple of minutes in your database and been back up and running, and then waited for CU3 and tested it. And if it didn't work, you could have gone back to CU1 instantly. Now, to me, that's one of these fantastic things that Microsoft's done. And that alone, I think, makes a good case for thinking about moving to containers. Now, you've seen me work with containers here for, I don't know, what is it, 45 minutes or so. They're a little bit cumbersome, right? It's a little bit, it's a lot of typing sometimes. It's a little bit daunting. So one of the things that people have found over time is that is very true, that containers are difficult to manage at any kind of scale, especially for ops person. So what they did was they wanted to come up with a way to orchestrate these. And there's been many choices over the years, but Kubernetes has kind of become the main one. Now, if you look on the internet, you may see it abbreviated as K8s. And for a long time, I wondered why that was. And then somebody finally explained that it's because there's 8 letters in Kubernetes between the K and the S. And so they just call it K8s. But it's Kubernetes. Either you look for Kubernetes or K8s and you'll find it. And what this is an orchestration or a management engine for containers. It's not the first one. It's not the last one. Docker had their own. Apache has their own. There have been many orchestration engines. But for whatever reason, and maybe because Google really pushed it, Kubernetes has kind of become the de facto orchestration engine that most people work with. As a matter of fact, you can go buy Kubernetes installations from Google or Microsoft or Amazon or multiple places, and they'll run it because it is a complex system. And all you have to do is upload your images and just give it configuration files and say go. And what it really is it's clustering software that groups machines together, almost like a big Borg or a big set of resources. And then you tell it what types of machines you need and what types of resources you need for your containers, and Kubernetes manages that. And it's phenomenal the way that that works. So I can take a container the developer built, I can take it to AWS or Google Compute Engine or Azure, and I can drop it in a Kubernetes cluster, and I can say, give me 5 copies of this, and it'll run the same everywhere. That's a huge advantage. Now, the way Kubernetes really works is it builds all these structures and puts them together, and then it manages the work. So pods are groups of containers. Right? So it could be one or more containers that you put together that you say, I need these all to be together to work in some way. And so then I decide, how many pods do I need to actually run things? And so a replica set would be a group of pods, which I might say, give me my web servers across 6 machines. So I need 6 replicate sets that can't be co-located on the same physical hardware. Just run them somewhere. And if one of those machines dies, Kubernetes spins them up on a different machine. Or if one gets overloaded, you can set resource governance and it can move it to another place as well. Services are what we expose to the outside world. So for the database side, we might say, I have a SQL Server service running in this pod. And there's 2 replica sets, and it's on 1433, and then people can connect to it. Volumes are for storage, just like I do in containers. I do that in namespaces, just like in any other coding thing. Namespaces allow me to have the same name of thing in multiple places without some kind of collision. Deployments allow me to say I want to do upgrades. So that's always a challenge, right? If I want to upgrade servers, how do I decide which ones to do in which order and to bring them up and down appropriately? In a Kubernetes deployment, I can tell Kubernetes the rules for how I need these containers to be stopped, started, and upgraded, and it'll handle it for me. And then, of course, load balancers are for moving traffic around, and there's plenty more. But essentially, Kubernetes is the management engine that will run all the software that I need to have my application work. So how does all this fit together? So Microsoft started containers in 2016. They built a few on Windows. There's a company called Windocs that actually built some Docker interfaces to support 2012 for them. But Microsoft has really said that from 2017 onward, that's where the container thing really works for us. We have Windows and Linux. We can do upgrade, downgrade through CUs, and we have all those images in the Microsoft Container Registry. So they've started to really support SQL Server in this way. 2017 didn't make a big shift, and I'm not sure that I would have run containers in 2017, but 2019 is a huge difference. And there's a couple of reasons why this is there. The first one is the separation of compute and storage has come to SQL Server. And then the second one is declarative HADR. So I'll start with HADR. I don't know how many of you have actually run availability groups or you've had to deal with it. It's a very neat technology. It's gotten much, much better from 2012 on. But the one thing that I would say is that the listener is a piece of junk and it's a mess. Okay. This is the thing that Microsoft has been trying to build. They kind of had it working and they pulled it. But what they've done is we want to be able to run an availability group in Kubernetes, which means that I would have a YAML file that would say, I need, in this case, 3 replicas that need to be on separate nodes, right? Inside my pod, I have a container for SQL Server, I have a container for the agent. I need the networking to connect those two together. If I need a certain number of CPU and RAM and all that, I have volumes that I need allocated. So I need, a terabyte of disk space or whatever it is. And I would present that to Kubernetes, and Kubernetes would instantiate it. Right? If one of these nodes were to fail, the SQL Server AG portion would automatically fail over to another one, because that's SQL Server. But Kubernetes would then find another node and spin up a third replica somewhere else, allocate the storage, and then SQL Server would then start to do the AG work. But Kubernetes then also handles the listener piece of this by providing a service and a load balancer that it exposes to the outside world. So no longer do I need to worry about the listener at all. I don't even have to have the clients config. The clients can just go to a service, a normal IP. And if it happens to die or move, Kubernetes handles the movement of that traffic to the other place. More importantly, I could have multiple copies of this. So I could have one for reporting, one for primary. That could be completely separate, that I could give out to different people with different types of configurations in there. The key to all this would be what's called an operator, which is its own type of software that helps manage your particular software configuration. And Microsoft had this kind of working in 2017. They pulled it from RTM for 2019. They haven't released it yet. I do expect it to come out here sometime soon. But once that happens, then the viability of SQL Server and containers running inside of a cloud environment becomes an order of magnitude simpler than it is today. It just does. It's amazing. The second part of this, though, and this is the thing that we have in big data clusters now, and I do think we'll actually get at some point inside of normal OLTP SQL Server, is this separation of compute and storage. I don't know that we'll get it in the next version of SQL Server. I think it might take a couple versions, but this is similar to the architecture that Hyperscale runs under. And the idea is that we want to have a way to scale things out. So inside of a large Kubernetes cluster, I have a couple of different planes. So I have these SQL Server nodes that just do computation. They have their own internal cache. They have their buffer pool, but they're a compute engine to run queries and return results. They actually talk to another set of SQL Server nodes that just act as data servers. So they live between the physical storage, and they essentially act as a second level cache for SQL Server. And then you obviously need to know where the data is, so there's some coordination here of how this happens. But what we can do, though, is I can scale out that compute plane if I need more resources. And I can scale out the data plane as my data needs grow, but I don't have to do those together. So I get some true scalability. And this is what happens in big data clusters. Each one of these nodes that says SQL inside of a pod is a container. And because there's so many of them, because you may have 5 or 10 or 20 or 50, you need an engine to manage these. And the same thing for the data. Now, on the data sides, in big data clusters, we can talk to HDFS or Spark nodes or SQL nodes. But the idea is that there are just data in their storage that we've separated out from the compute engine, which is what a lot of us have wanted for a long time. And that's kind of that holy grail of being able to scale things out. Now, there's other stuff in here to manage this. And of course, once you're talking about a system that includes, 10 or 20 or 50 servers, it can be a nightmare to manage if you don't have a lot of controls. And that's where Kubernetes as an orchestration engine comes into play. You can do this today with big data clusters. They don't support it for normal SQL Server, but they do support it for big data clusters. However, Microsoft does some hand-holding with this, and you buy it as a subscription, not as a license. So most of us won't do the big data cluster thing, though there are people out there that will show you how you can set this up with 4 nodes in your own Kubernetes or an Azure Kubernetes service if you want to play with it and work with it. But this is going to fundamentally change the SQL Server world in 10 years when most of us are on SQL Server 20 or 21 or 22 or 25, and we have the ability to scale out not these huge servers, but imagine that each one of these pods in the middle is 4 cores. And I decide things are running slow, I'm just going to add 4 more cores to my SQL Server on another machine with its own buffer pool and its own ability to then satisfy queries from reporting or from additional workload from OLTP or anything else. It's a phenomenal idea, and this is where I think containers dramatically change the game. So that's most of what I covered. It's kind of the summary. A container is a virtual view of the OS, really. That's what it is. And when I run containers, I'm running instances of the image that I've created. For SQL Server, right now, the big win is the upgrade and downgrade that you could do. Being able to go apply and get rid of CUs is huge. And that time savings, being able to do it in a couple of minutes, means I could possibly apply 3 upgrades and still have 5 nines availability in a year. I couldn't do that without a container. Kubernetes is an orchestration engine that manages containers at scale because none of us want to manage containers at scale. It's a nightmare, it's a hassle, and it's very difficult. And I really do think that the future of container or SQL Server is going to be in containers. I think it's probably 10 years away, but I think that's where we're all going. So hopefully you've enjoyed that. Any questions? Steve, anything from you? Anybody still there?
Yes.
Yes, we're here.
Go ahead.
I have a question actually. How would you recommend to apply Kubernetes and SQL Server inside containers to data warehouse development when we deal with the huge data volumes, like low terabytes right out of the gate pretty much?
So the storage piece is separate, right? You got to remember that that's separate. So the way that you have to deal with storage now is really no different, right? Like if you need additional storage, or if you're upgrading your data warehouse right now on premise, right? None of that storage for my data is probably on that machine, right? It's probably on a LUN or multiple LUNs somewhere. And what I'm going to do is install a new system. I'm going to test it, make sure it's right. And then what I'm going to do is attach those LUNs and just attach those databases to my data warehouse. So that would be the same thing you could do here, right? When I'm doing this upgrade downgrade, it's essentially, attaching that storage to the new instance of SQL Server that just started up. So in many ways, it's no different than what you do today.
I have a follow-up question. How would you create a sandbox with the, let's say, feasible data, I don't know, for the data that makes sense for developers so they could play, but not kind of accessing the whole data volume that lives in the data warehouse?
So that's a huge challenge, right? Like that's really no different than what you would do today, right? That ultimately to give developers something, to give developers a copy, I really have 2 types of choices, right? I can allocate space on a SAN and do a snap, and then give 5 developers that can share a copy of the full data warehouse, which is expensive, but it's the real data, right? There's all sorts of pluses and minuses. Or what I always recommend for our customers is that you take the time to build and maintain a representative data set for your warehouse that is of a reasonable size. It's a gig, it's 10 gig, it's 20 gig, but it's a reasonable size. And then as far as deploying that in a container, it would be up to you. I do have people that work with containers that like to get that data set down to a gig, and then they put it inside the container, so it's inside the image, and then they give everybody the image and they restart it. I also have people that go, we use file technology and we'll make a few copies of that around, and then you attach that file to a SQL Server, or we attach it to a container. The containers don't really change that problem or change what's going on there.
Oh, that makes sense. Again, you can carve out the data the way you want and kind of make the data volume more manageable. Yeah, I get it. Thank you.
If you make it very manageable, then you can stick it in a container, and the advantage there is then everybody guarantees they always start with the same thing, right? So if I blow up my ETL load that I'm practicing, I can just delete the container and start a new one, and it restarts quickly, and it looks like it was when I started.
It's more not even for ETL load. ETL load, I mean, I have separate staging area. I mean, I can create copies of incremental tables. I mean, that's comparative under control. I mean, I'm thinking about like DAX development when I actually need to do some, develop pretty much on the comparative of the data. And I would like to create a copy, but again, there is no kind of way around doing it, I'd say in
if you're just doing DAX stuff, containers don't make it any easier. I mean, they do ensure that what you guys do in development, it looks like what goes to QA, looks like what goes to production from the infrastructure side, but it doesn't change the problems of a data size issue, in how the developers work with it, because it's just SQL Server, or it's just analysis services, right?
Yeah, I get it. Analysis services in the Okay, yeah. No, makes sense. All right.
Yeah. Anybody else?
Steve, I have a quick question. So I have a nightly process where I need, say, like 10 container instances, right? Running only for 2 hours, and each container is going to have 4 CPUs. So in this case, right, they are needed only during the night, only for 2 hours. So in this case, right, how does the licensing work?
Licensing is licensing. The licensing for containers is exactly like licensing for VMs. You have to pay for anything you've allocated out, like you can't,
it's not like pay-per-use, or do we need to have a perpetual license?
Yep. It's just like you had a VM or another machine. I mean, containers like having another machine. So yeah, you have to pay for that.
Okay, I see. Okay.
I mean, if you want to pay for use, you got to go to Azure.
Oh yeah, right. Okay.
Yeah. I mean, there's things you do like Azure Data Factory or something. I'm going the wrong way. That would do that kind of stuff. So yeah, there's no licensing break, no magic here. I'll send this deck to you, Steve, so you have it. But there's resources here, and then if you want to get a hold of me, anybody should get a hold of me. Feel free.
Steve, in terms of cost, so not licensing, but the main point would be that containers save you money because you utilizing less resources.
No, I mean, no, not at all. Containers are all about, really it would be labor, right? Saving labor and consistency and rework and all the other things that happen. I mean, I guess it could save you money in development side because I can stack them, or in the database side, you're not going to save any money because we need the resources we need, right? There's no magic here. But let's say that I have web servers, right? My web servers, I have to serve lots of content. I could stack multiple web servers on a machine. I could have more of them running than I could if I had VMs running, right?
You utilize better. Okay.
I could utilize better. The places where I've seen a lot of advantage with this is people that have these small microservice type processes. So they've got ETL processes that run as small jobs, or they've got some sort of service that has to respond to things. When you think of serverless type of things, that's the type of stuff that I see people build. And in those cases, they may have thousands of instances in containers running on one machine, as opposed to hundreds running on VMs. So from the software side of saving money, I think if you run Java, because Java is just a piece of junk and crashes a lot, right? You run Java Beans, Tomcat, containers are huge there because I can stack the density much higher. But for us as database professionals, it's not helpful because we need all the resources we can get, right? We're not typically slicing machines. We're usually like, give us the whole machine so this will work. Does that make sense?
Yep. Now, in terms of companies that trying to adopt containers, so let's say you have 10 servers in production. How you can take advantage of containers? So meaning, what strategy would you have to introduce containers? Because you already have something existing.
So where I think containers start to fit a lot is in smoothing that process of getting stuff built out of development and then ensuring that it's deployed to production. So I would probably start in the software side of things. I think making the change on SQL Server is tough because unless you've changed to Linux, I don't know that I would make that change right now. Like I said, I think this is more the future of SQL Server than it is right now. But if I was going on 2019, I might think about moving to Linux and moving to containers there because it's just SQL Server and it just runs. And then I have those advantages of upgrade, downgrade very, very quickly without downtime. On the software side of things, if you're doing any place where you have Java or PHP, places where versioning really matters, C, C++, containers are huge because then I can guarantee that what the developer built was what will run. I don't have to worry that somebody updated something somewhere in the wrong time and I wasn't aware of it. So it really shines in the Java world in places where I've got versioning issues. In the .NET world, we can run multiple versions of .NET without conflict, so we have less issues there. But if you have a place where I'm trying to ensure consistency or I want to make sure that there's never anybody trying to download .NET, that we're guaranteed that this piece of software runs on .NET 4.5, and so we want to make sure it works. Their containers start to make sense because they enforce the consistency between the development areas, the test areas, and the production areas.
Got it.
So, yeah.
I have another question. There is a talk a lot kind of in scope of SQL 2019 about big data clusters and data virtualization. And again, if we try to interject data warehousing here, any thoughts of this? I mean, any strategies that you would kind of recommend to your clients?
You have to just go investigate it and see. I mean, big data clusters, I think they give you tremendous scalability of resources, but they certainly, if you're already in that world where you're thinking, I've got data in HDFS, or I've got people that do Spark type stuff. This kind of, it smooths the process if you're a Microsoft stack company, but it also creates there's a lot of overhead to getting it up and running and understanding how it works. And then, you need a sandbox environment for that.
Yeah, and it's not small. It's like 8 cores and 64 gig data command, actually.
Yeah, I mean, I think you've got to be willing to run Kubernetes to do it, which that's a daunting task. I mean, Kubernetes is a very complex thing to run on premises. I mean, I wouldn't even bother. Like, it's a snap in Azure, but then it has to make sense for you to go to Azure, and you have to be willing to try it there. But running Kubernetes, I wouldn't run Kubernetes. I'd let Microsoft or Amazon or somebody run it for me. And I think it's getting better and better. But if you want to look at big data clusters, you have to really think hard about, it's a big investment.
Agreed.
Yeah. I mean, I would stand it up in Microsoft first and see what you think, because you could set up 10 cores, right? 5 cores in Azure and experiment and go, do we think this is actually helpful? And then decide, is it worth investing further? But I think you'd have to take it in stages. And the same thing with containers. Like, I think containers are amazing. We're starting to use them a lot at Redgate, but it's been over a year of us talking about it and trying to figure out how to do it. It's not something you're going to do quickly.
I see. That was my feeling too.
Yeah, they're super cool. They're the future, but they're not the future this year.
All right. Okay. Any good books that you would recommend on? I don't know. I mean, I know SQL 19 Revealed by Bob Ward, probably a good book, but maybe a couple other books. I mean, anything else?
I haven't found a lot of books. I tell you what, some of the best stuff I've seen is on Pluralsight. So somewhere in here, Nigel Poulton has some great stuff on Kubernetes and Pluralsight. Anthony's done a bunch of courses as well, and I think that most of the people that are really moving quickly here and helping you get better at this stuff are doing more stuff like Pluralsight than they are actually writing books. Kubernetes today is vastly different than Kubernetes from last summer.
Yep. Okay. Okay. No, I mean,
Yeah.
oh, they have something on edX. Interesting. I see. Oh, okay.
Steve, so do we have, what is the equivalent of Kubernetes in Azure?
Yeah, so Kubernetes is Kubernetes, right? That's one of the advantages, that it provides a standard platform. So Kubernetes has the AKS, Azure Kubernetes Service. Amazon has a Kubernetes service, and Google has a Kubernetes service. And the great thing about it is that you could take the same YAML file or Helm chart and the same images, and you could move it from Amazon to Google, and it would run the same. I mean, you get a different IP, right? But it would run the same. So that's the huge advantage of containers too, is that I'm not locked into Azure or AWS, right? If I go to containers, I can run them anywhere I want.
Oh, okay. Thank you. Yeah. Looks like what I'm finding is like one good use of containers for the database guy is like, if you have a nightly batch processors which needs a lot of processors, CPU or memory, right? You can spin up container instances and connect to the central database servers, pull the records, do the processing, and then update the central production server. Then destroy the containers, right?
It can, but it's not going to be. That kind of use is not any different than it not being a container, like just being a normal instance on a VM. That's not. There's no great advantage to that.
Oh yeah. Oh, okay.
Right, because because you still you got to pay for the licensing anyway. So whether it runs all day or runs for 10 minutes, there's no you get nothing from doing it like that.
Yeah, exactly. Yeah, only thing is if you want to run in a different version, right?
So if you need a task to run things in different versions, know, on the same machine, or like for dev test, it's huge. For production, it's slightly better, though the upgrade downgrade is the big thing in production right now. For dev test, though, it's fantastic, right? Like if you go, I have to run on 2017 and 2019, developers can spin up and spin down default instances, which is fantastic, right? Because named instances are a pain.
Right. Yeah. And also there maybe we could take advantage of the enhancements for the query store things, right? That's available with the different versions. So that goes more into internals.
Yeah, I mean, you can see all that stuff. You can test things against each other, right? I mean, it's it really, I mean, even as an individual working on a laptop, the overhead of an instance administration is a pain, because as soon as something doesn't work exactly like you want it, you've lost an hour or something trying to make something work. Containers just simplify that.
Yeah, I see that. Yeah, exactly.
So.
Yeah.
Anybody else?
No, thank you so much for the presentation.
You're welcome.
Thank you, Steve. Yeah, thank you so much. It's really informational.
Good. You're quite welcome. I'm glad you enjoyed it, and hopefully I'll get out there and see you guys live at some point soon. Hopefully.
So hopefully not. Probably not in the recent next 3 months. Maybe it's after that.
Let's hope. Let's hope.
Let's hope.
We can get there.
Yeah.
So, all right. Well, enjoy. I'm gonna go. I'm gonna call it a night.
Yeah. Sure. Yeah. Good night.
All right. Thank you,
Steve.
Steve.
Thank you
my
all.
pleasure. I will talk to you soon.
Thank you.
All right.
Good night.
Bye.